Hi, my name is Juan Rojas, and I'm going to talk to you about MR fluids. First, I'm going to give you a little introduction on how they work.
MR fluids consist of magnetic particles, usually in the micron scale. This size separates them from ferrous fluids, which usually contain particles in the nanoscale. The particles are suspending in a medium, which is usually an oil, and a lot of research goes into keeping these particles suspended in the medium over time. So this is what the fluid looks like without a magnetic field applied to it. When you apply a magnetic field, the particles align parallel to the magnetic field and motion perpendicular to the magnetic field is opposed. This makes the fluid more viscous.
So the main application for MR fluids is for making dampers for heavy machineries and nowadays expensive cars. So I thought I would just make my own little suspension. So I have here a damper, which is basically a PVC tube that has the MR fluid inside. It has a piston that goes through the fluid. And then here is the spring that I'm using. First, I try to make my own MR fluid using iron filings and oil. But as you can see, I don't know if you can see, there's a lot of sedimentation at the bottom. It doesn't really mix evenly, so it just truly doesn't work for my purposes. So then Dr. Buckner provided me with some MR fluid, and that's what I'm using here today. It's very thick in the bottle, so I just use some water to dilute it. The next thing that I had to come up with is how to provide the magnetic field. So at first I tried making coils, and I made this one and a couple more, but it really just wasn't enough, not nearly enough. So then I just got a hold of a couple of neodymium magnets, like the ones we talk about in class, and I just stacked them to get different magnetic fields. So I don't believe that 3 stacked together are 3 times as strong as just one magnet, but they are stronger. So if we go back to here to the suspension, if I just push down on it, there's a little resistance. But if I put one of the magnets here, you can see the oscillations are less and it's a lot more resistance. Now if I use this weight, it's 1 kilogram weight, put it on there, so I can press the spring pretty much all the way down. If I put 3 of them on there, it doesn't really compress it that much. And I did this test with 1 magnet, 2 magnets, 3 magnets, 4 magnets, 5 magnets, and then 6 magnets stuck together. And then I plotted the relative viscosity.
Viscosity is calculated by measuring how long it takes an object to move to the fluid a certain distance. Since it took a large weight to move the piston when a strong magnetic field was used, the 6 magnets, when I used the same weight for the weaker fields, the piston moved very rapidly, and it was impossible for me to measure that time accurately. But the purpose of this demo is to show that viscosity increases with an increasing magnetic field strength, so the exact values are not necessary. Therefore, I just plotted the weight it took to move the piston using the different fields, and that's what you see in this graph. As you can see, as the magnetic field increases, it becomes harder to push the piston. Even though the values for the viscosity were not calculated, the shape of the graph looks like the top half of the theoretical values found in the MR fluid datasheet. This concludes my presentation. I hope you enjoyed it.